So in this question we are given that a particle moves along the x-axis with the velocity v of t given by this function, and for the time period between 0 and 3.5 seconds. And the position of this particle at time 0 is -5. So the question is, first part A, find the acceleration of the particle at time t equals 3. And so we need to find v prime and evaluate it at the point 3. So we can do that numerically on a calculator. So let's do that. So let's calculate this derivative. And we go to Math, Derivative with respect to x of the expression 10 times sine in parentheses 0.4 times x squared, and it doesn't matter whether we use x or t here as long as we are using the same variable, divided by, in parentheses, x squared minus x plus 3, close parentheses, and then we evaluate this derivative at a point t equals 3. And so the value is -2.118 thousandths. And so this is the acceleration of the particle at time t equals 3. So in this part of the question, we are being asked to find the position of the particle at time t equals 3. And so what is that position? Let's denote it x of 3 is equal to position at time 0 plus integral from 0 to 3 v of t dt. And so plugging in the numbers and the formulas, we get -5 plus integral from 0 to 3 10 sine 0.4 t squared over t squared minus t plus 3 dt. And this is need to be evaluated using the calculator. So let's do that next. Let's calculate this expression here for position at time t. So first it's -5 plus, that's the position at time 0, plus integral, mathematics, integral from 0 to 3 of the function 10 times sine of 0.4 times x squared, close parentheses, divided by, in parentheses, x squared minus x plus 3, close parentheses, and the variable is x. So enter, and we have the -1.760. So the position of the particle at time t equals 3 is -1.760 thousandths. In this part of the question we are being given two integrals and asked to evaluate them using the calculator, and we'll do that next. But what are those? This is the displacement of the particle over the time interval from 0 to 3.5. So this is a velocity, integral of velocity gives us the displacement. This expression here is the speed of the particle. So overall this integral is the total distance traveled by this particle over the time interval from 0 to 3.5. So this is the displacement, this is the total distance traveled. So let's calculate those using the calculator. So let's first calculate the displacement, and this is mathematics, integral from 0 to 3.5 of the velocity, and so velocity is 10 times sine of 0.4 times x squared divided by, in parentheses, x squared minus x plus 3 close parentheses, and this is with respect to x. And so 2.844 thousandths, that's the displacement of the particle during this time interval. Let's now calculate the total distance traveled during this time, and we go to math, integral from 0 to 3.5 of the absolute value of velocity, in this case, absolute value of velocity, which is 10 times sine 0.4 times x squared, close parentheses, divided by, in parentheses, x squared minus x plus 3 close parentheses, and this is with respect to x. So let's see what this gives us. This gives us that the total distance traveled by the particle over this time interval is 3.737 thousandths. In this question, we are being given a second particle which moves along the x-axis with the position given by this function, t squared minus t, for the same time interval 0 to 3.5. And we need to find time at which both particles move with the same velocity. So we need to first find the velocity of the second particle, which is x prime of t, which is a derivative, which is 2t minus 1, if we differentiate this. And so they will have the same velocity at the time t at which this is equal to v of t. So we can find such t that this is true, or rewrite for the calculator v of t, which is 10 sine 0.4 t squared over t squared minus t plus 3 minus 2t minus 1 equals 0. We need to find all the solutions of this expression, and we'll do that with a calculator next. So let's find all zeros of this function, and so let's go to plotted. So the function is 10 times sine of 0.4 times x squared, close parentheses, divided by, open parentheses, x squared minus x plus 3, close parentheses, and then we need to subtract 2 times x minus 1, close parentheses. So let's see what the window we have. So the window should be between 0 and 3.5, which is given to us, and then let's do the scale of 0.5. Let's see what the graph shows. And so you can see here that the only zero is at about 0.1, 0.5. This is about where it is. So there is only one solution, and so let's do window between 1.4 and let's say 1.6, and again, if we make a mistake here, we can always change this range to be more precise. 0.1, and let's just decrease this range from 0.1, from 1 to 1. And let's see, let's graph it. So we can see that time is somewhere in this range here. So let's now do tracing and move to the right until we hit y of approximately 0 here. And so this is the point. We can see that x, or time, is 1.57 hundredths. So the answer is at a time 1.57 hundredths, the two particles are moving with the same velocity. And that is our answer here. Thank you, and I will see you in the next video.